Hello and welcome. I am Vishwanathan. In this video, let us try to learn and understand the sixth program of Artificial Intelligence and Machine Learning Laboratory of VTU. The sixth program is titled Naïve Bias Classifier. This is also an important topic in theory exams. To understand this program, it is very essential to have a good understanding of this dataset, that is diabetes.csv, and also there is an important formula which we need to remember in order to be able to write the program well. Okay, now in this program we use this dataset called diabetes.csv. This dataset is basically owned by this institute called National Institute of Diabetes, and it goes on. And it was the dataset was initially formed or created by Johns Hopkins University. The dataset contains about 8 attributes, totally 8 attributes it contains, and it contains one output. So, and the dataset is exclusively for females, that is why we see a column called pregnancy here, and those females are 21 years older than 21 years of age, and they belong to this Pima Indian heritage. Okay, now what this dataset tells is, it will have the data for these 8 columns: pregnancies, glucose, the blood pressure, skin thickness, insulin, body mass index. DPF is a function, diabetic pediatric function, and age. So based on these 6 attributes or columns, we will have an outcome. If it is 1, it means they are diabetic, and if it is 0, it means they are non-diabetic. So this is what the dataset contains, and this is the dataset we are using. And what we are trying to do here is, we have the dataset. The dataset contains totally about 768 rows. What we are doing in this program is, we will split the dataset into training and testing dataset, and we will use this Naïve bias classifier on the test dataset to analyze how good the accuracy and efficiency of this Naïve bias classifier is. In other words, we already have the outcomes. That is, for example, for the first row, the outcome is already 1. But what we do is, we will out of the 768 rows, we split it into training and testing, and we will use the Naïve bias classifier concept, that is the formula which gives the probability for the prediction, and we will come up with the result for the outcome, and ultimately we compare the actual values and predictions, and we print the accuracy. This is the overview of the program. Now, in order to understand how the program is written, most of the functions can be understood except one, that is the function called calculate probability. So the function prototype is self-explanatory, that is, it takes x, mean and standard deviation, but the code written here is very difficult to understand without knowing this formula. So this formula is the theory doesn't give you any derivation or the basis from which the formula is obtained, but this formula has to be memorized. So this is the probability value. The formula goes like this: it is 1 by square root of 2 pi sigma square, where sigma is the standard deviation, into e power minus 1 by 2 sigma square multiplied by di minus mu whole square. Here mu is like the mean. So if we remember this formula, writing this program becomes a lot easier. And in this function, that is calculate probability, we are just translating this mathematical formula into Python code, and the same is written here. We will understand this while understanding the code. So that was the introduction for the program. Now let us get into the actual program. So we import the 3 required modules: CSV, random and math. Like any other program, we just open the dataset using the open function, and here we are processing it as a list, and ultimately we are returning the dataset. Dataset will contain 768 items, that is 768 rows. So as you can see here, it will be the values for each of the 8 columns, that is each of the 8 attributes, and the last column will have the outcome, that is whether the person is diabetic or not. So that is what we are doing in this load CSV function. Okay, what does this function do? Split dataset. The very name says it will just split the dataset into training and testing dataset. So what is the split ratio? split ratio is a parameter which the examiner can give, or we can assume. You can take any random values, but normally we take 75 to 25, or we can take 90 is to 10. That is, training set will have 90% of the columns, and the test set will have 10%. So we have assumed 0.9 here, and the 0.9, this function is called from the main function, or it comes in the later part of the code, but let us understand this part of the code here. So from this split ratio, which is a decimal number, that is 0.9, we are trying to get the number of rows that will be in the training size. So this is self-understandable. Int of length of data set, this will be 768 into 0.9. So this will come up to some number. It will be an integer, and that will be stored in train size. Next, we are simply using the concept of slicing. So this is very simple. We are just processing the data set from the starting, the first row, up to the train size, that particular row, but that is not included, and that will be stored in train dataset, and the remaining part of the dataset, that is starting from train size, this will be included until the last row, that will be stored in the test dataset. So, and ultimately we are returning the training dataset and test dataset. That is what this function is doing. Next, the reason for this meaning, calculating this mean and standard deviation is already understood, because these are important parameters for this function, calculate probability. So mean is, in any other normal meaning, it just means the sum of numbers divided by the total number of numbers, that is length of numbers. So this length of numbers will give number of numbers, that in other words number of data instances. That is what we are calculating in this function. Standard deviation also is self-explanatory. We just find the average, and we know the standard deviation formula is square root of x minus average, that is the mean, whole square, that will give the variance, and the square root of variance is nothing but the standard deviation. That is what is done in this function. Next, now we see a function called summarize by class. So what does this mean? We know class in this particular data set means the outcome column, that is the last column in the data set. So class will be either 0 or 1. So what does summarize mean? In a way, in this function, we are trying to get some sort of information in the form of a summary for each of the two classes. That is, we can understand the function like this. This function is aimed at doing a summary for each of the class, that is for class 0 and class 1. So we can understand the code here. We create a dictionary, empty dictionary called separated, and we traverse to the data set, the entire data set. Now what is vector here? Vector is equal to data set of I, that is each instance of the data set, that is each row of the data set, we are storing it in a variable called vector. And vector of -1, what does this mean? It is, if each of the row is a vector, then the last column index is -1, so the last column is nothing but outcome. So what we are doing in this separated dictionary, we will create, that is we will create key. The key will be the class value, that is vector of -1 will be either 0 or 1. So that is what we are doing here. If vector of -1 is not in separated, then we create a empty list for that particular key. So that is what we can understand here. The for 0 we will create a list, for 1 we will create a list, and 1 if it is not there. Suppose we have already created a list for 0, this part of the code is not executed. If it is not in the separated dictionary, only then this line will be executed. That is, it will create a new key and a list respectively. So once we have the list for 0 and 1, for every instance of the data set, we will just append the vector. That is what we are doing here. And so by doing this, what we have got, as of now we have simply got the data sets for in a way we have got the data instances for all the data instances for which the class value is 0, and for all the data instances for which the class value is 1. That is what this separated dictionary holds. Now, but the function is aimed at doing the summary, that is a summarize. So again we are creating a summaries dictionary, empty dictionary. Now as I said, separated is a dictionary, separated at items. What will it contain? It will contain one item for the class label 0 and one item for the class label 1. So class value, that is what I mean by class label. So this will be either 0 or 1, and this is the instance, that is the row values. So we are creating summaries of class values, that is summaries for class label 1 or class label 0, and we are just using the values mean and standard deviation for each of the attributes. That is what we are doing here. This can be understood. So mean of attribute comma standard deviation of attribute for every attribute in the zip of instances except the last one. So because the last one is just the outcome which will have 0 1, so the meaning of mean and standard deviation will have no meaning for that last column. So except for that last column, for every other attribute, that is we have 8 attributes in the data set, for every other attribute we are storing this mean and standard deviation in this summaries dictionary, and this function will just return the summaries dictionary. Now we are done with nearly 50% of the code. Next, calculate probability. This is the most important function in this program. The reason for this complexity in the code is already explained. It is just the translation of the mathematical formula into the Python. So here we are just in the formula which we already discussed, we are having it here. So in the formula we already discussed, it has two terms, that is this is one term and this is other term. In this function we are creating the second term first. So exponent is equals to, it is very clear, math dot exponent. So it is nothing but e power and minus is written here, x minus mean. When we see double star, it means power in Python. So x minus mean the whole square divided by, that is it is divided by 2 into standard deviation whole square. So the second part of the formula is calculated here in the variable called exponent, and then before returning, so this is the ultimate return value p. So we are returning 1 by square root of math dot square root of 2 dot. So in order to get the value of pi, we use this math module, that is math dot pi multiplied with the standard deviation square. So if we remember this formula, writing this part of the code is easy. It is just the translation into Python. So we have understood this function, which is very essential. After this we will just see the remaining part of the code. Once we have got the function which will calculate the probability, so we are having a function called as predict. So what does this predict do? It will take the summaries and it will take the input vector. Input vector is actually the test set. So while execution, this get predictions will be called first. That can be understood here. See, predictions is equals to get predictions. We are calling the get predictions function by passing summaries and test set. So this part of the code will be executed. So this test set will be traversed in this for loop, and we will call the predict function for each of the instance in the testing data set. So this input vector is nothing but each instance in the testing data set. So it will use the summaries and the instance of the testing data set as represented by this variable called input vector. Then what we are doing here, we are creating an empty dictionary called probabilities, and class value, as I said, it is nothing but 0 or 1. Class summaries will what be contained in the summaries dictionary. As I said, summaries dictionary will just have, we can see it here, summaries dictionary will just have mean and standard deviation for every attribute, that for all the 8 attributes in the data set. So we are just traversing the dictionary. Initially we just assume that the probability of the class value is 1. Then we have a for loop which will go through the entire dictionary, which will go through the entire dictionary, that is class summaries. Summaries dot items will return class values and class summaries. So it will traverse the class summaries. As I said, it will just extract the mean and standard deviation. Then it will pass mean, standard deviation and the data value to this calculate probability function. So this is the major implementation wise, this is the most important line of the code. In order for the why the program is working is because of this part of the code. So it will calculate the probability, and whatever it is returned, it will be stored in the probabilities dictionary. Probabilities of class value will be updated. So initially we just assume it is 1. Ultimately we calculate and we update it. Then this will go on, and initially it will be 1, that is the probability value will be 1, but then it will be updated. So once we are done with the entire, because we are traversing the entire testing data set, so for each of the instance we will have what is called as best label and best probability. Best label will be initialized to none and best probability will be initialized to -1. So since we are calculating and we are updating, so we just do this comparison. Initially this best label will be none, obviously, and the probability initially will be the best label will be none and best probability will be -1. So in the first iteration this will also be satisfied, and because it is -1, this will also be satisfied, the second part of the OR statement. And what will happen is best probability will be assigned the probability value and best label will be assigned the class label. So you must remember, class value will be having the value either 0 or 1. So this function we have in a way understood, and ultimately this function will return the best label. Best label means for a given instance, that is for a given row in the data set, what is the label. So will it be 0 or 1 according to this naive Bayes classifier. So get predictions function is a much simpler function. We are just taking the parameters from the main function, that is main part of the code, and we just create this empty list called predictions, and we call this predict function, which will do all the computations and it will return the result, and whatever is returned as the result will be appended to this list. So ultimately this will have the predictions list for each of the row in the data set. Get accuracy is also very simple. What we do here is we will have the test set. Test set will have the output column as well. As I said, out of the 768 rows, we are splitting in the 90 to 10% ratio. 90% of this is 691 and 10% is 77. So these 77 rows will have the column value, will have the rows for all the 8 columns, also the output column. So in this get accuracy function, test set will have the output column as well. Predictions is what we have predicted, and this is a very basic code. So initially we assume that it is not correct, and if the test set of I of -1, that is what I mean, the last column, if it is equals to predictions of I, we just make the correct value as 1, and we just return the correctness value. So correctness value is nothing but accuracy. So this function will just return correct divided by length of test set, that is how many are correct and what is the total length of the data set. So out of the 77 rows, how many instances are having the correct prediction. That is what this part of the code is doing. We have almost come to the end of the program. Here we are just naming the file, that is diabetes2.csv. This CSV file will be given to us. While we are using Jupyter notebook, we must just make sure that the program, this whatever the name we give, .ipynb, this and diabetes2.csv must be stored in the same folder in the computer which we are executing a program. That is one important thing. Split ratio will be given. It can be, need not be 0.9 always, it can be even 0.75, 75 to 25 ratio. And data set, we are just calling this load function, load CSV function on this file name, and we will just come to know why this actual list required. We will just see that later, and then we will just create the testing and training data set by calling this function split data set. All this is already understood, and then what we do here is just for the sake of comparison, we just create this empty list called actual, and we just process, we just go through the entire testing data set and we store the last column value. So actual value you can see here 1.0, this is nothing but the outcome column, that is the last column values. So there will be 77 values here, for each of the 77 rows. That is what is contained in this actual variable. So this print statement is just giving the information that we are splitting the rows, total 768 rows. So length of data set, length of training set, and length of test set. That will be stored in 768, 691 and 77 respectively. And summaries is created, that is the variable summaries is created just to store the return value of the summarized by class. So what this summarized by classes will return is already understood. It will just take the training set, and for predictions we need summaries and test set. And get predictions is the function called, which is also understood. Get predictions will in turn call the function predict, which will do all the calculations. And here the most important function is calculate probability, which is also understood here. And so we just print the actual values just for the sake of comparison, and we print the predictions values. So just to appreciate the output, let us just see for the first row in the 77 rows, whatever we have considered for the testing data set, the last column is 1, so it is matching. Second data set is also matching. For many it matches. We can just assume, we can just see here for in some row in the testing data set, the actual outcome value is 1, but it has predicted as 0. And so accuracy is not 100%, it is 76.623%. This accuracy is calculated by this function called get accuracy, which is also understood just a little while back. So it will just, this is a simple computation which will just initialize correct to 0, and for every correct classification or for every correct prediction, it will increment the value of correct, and it will just return the accuracy value. So that accuracy is returned here. This was all about Naïve BAYES classifier. This program is quite understandable if we have understood the data set as well as the theory for this Naïve BAYES classifier. That was all in this video. Thank you.